Welcome everyone. I'm Raghu Ramakrishnan, the CTO for Data and a technical fellow here at Microsoft. And today I'm excited to tell you all about unified data governance with Azure Purview. So let's begin with the vision we have for what governance is becoming today. Increasingly, digital transformations hinge around this loop. You want to engage customers, empower employees, transform products, optimize operations, whatever it takes to make your business better. And the heart of this flywheel is observing anything and everything pertinent to these facets of your operation and to take that data, learn from it, take the insights you get and weave them right back into the applications that power your entire business. And at Microsoft, we want to empower you in every step of this digital feedback loop. From the applications that empower your employees, power all your different transformations, all the way to the back-end data platforms wherein those applications store their state, to the data platforms where they bring together data to analyze and get insights, right? The insights that then go back into the applications to make them better. We want to support this entire ecosystem for you. And a key part of that, as you see in this picture, is a tool for governance, for governing all your data throughout this life cycle. What's happening to create this increased attention around governance? In today's world, where data is not just in one or two database systems, but is spread all over, across clouds, across on-prem data sources, in databases from multiple vendors, in big data systems and file systems. In this world of ubiquitous data, simply understanding what data is available in your organization and what data you're responsible for can be a hard challenge. Beyond this, how do you know that you're doing the right thing? How do you know that your use of data throughout your organization is compliant with all the appropriate rules? And if it's not, do you have the ability to efficiently define the right policies and enforce them? This is the task facing chief data officers in every organization today. Traditionally, there are two kinds of data platforms: operational databases in which applications manage their state. These include SQL Server, the whole family of Azure products built on SQL Server, Cosmos DB, MySQL, MariaDB, PostgreSQL, Dataverse, and these are systems whose performance is traditionally measured by benchmarks like TPCC. And then there are the analytic systems. Our own Azure Synapse Analytics brings together data lakes, data warehouses, and the performance in this space is measured by benchmarks, again, industry standard like TPCDS or TPCH. It's also becoming clear that as you want to analyze data ever more comprehensively, you want to be able to bring the data in your operational databases into the ambit of your analytic environment. And we make this easy through a powerful new feature called Synapse Link. Essentially, any operational data can be automatically mirrored incrementally by us. So you don't have to worry about it, and you can just go ahead and analyze it in Synapse as if it were there. However, what I'm going to talk about today is an emerging third pillar. Governance hitherto has been a feature inside SQL Server, inside a traditional database system. But in a world where your data is not in just one instance of SQL Server, when it's sprawling all over the place, multiple database platforms, on-prem, other clouds, Azure, you need something that doesn't quite exist. You need a unified governance platform for all your data. And this space is rapidly becoming a third pillar on par with operational and analytical databases. And let's be clear, governance cannot be an island. Your governance platform must enable you to have full visibility into all your operational and analytic data and how it's being used. And I don't just mean the data in Microsoft systems or Azure. I'm including here all the data in your data estate, whether it's on-prem, on other clouds, other vendors, doesn't matter. You need to be able to have a single place to view it all and to act on it and to govern how it's used. Let's begin the story by taking a look at what Microsoft itself had to do to become compliant with the GDPR privacy regulation from Europe. Internally, Microsoft is an extremely data-driven company. Every part of the company, from Bing to Windows, Office, Teams, they use data about their operations to learn and to grow better. So every time there's an update, for example, on Windows, the telemetry from that is gathered and analyzed to see what went smoothly, what did not, and the next update will get better. If you look at the data underneath this, there's an internal lake which has over 10 exabytes of data. By any metric, this is a humongous analytic environment. Every part of Microsoft depends on it. As I said, over 10 exabytes of data, hundreds of thousands of physical servers, thousands of developers across virtually all teams at Microsoft. And it's not just this one environment. We have hundreds of SQL Server instances, Custo instances, which is a telemetry log analytics service we have. That's our estate. And when GDPR came along, to be frank, we realized we didn't have a comprehensive way to look at what data we had, an inventory, right? Who owned which piece of our inventory? The data sprawl defeated us. I need hardly say we didn't have ways of defining uniform policies of what was permissible, to whom, for what purpose, and enforcing any of that. And that's the lesson we learned. Unified data governance is a big need and a space that existing tools didn't cover. So we had to build our own. At our scale, certainly, we didn't have options. So the approach we took essentially was to scan our entire data estate, bring various classifiers to bear, and to essentially extract as much metadata, lineage, for example, as we could, and to instantiate a data map or an instance of the catalog that described everything at Microsoft that pertained to data. And the scales here are enormous. But this data map then enabled us to begin to get a handle on all those challenges I just described to you. And let's talk about the data map, which describes this sprawling data estate. There are over 37 million assets described in the data map. And over 95% of these, we know who the owner is. That number, by the way, is significantly up from where it was when we began the journey. Every month, we have over 41 million DSRs, or data subject requests. So you could come to Microsoft and say, what do you know about me? And you could say, hey, forget my search history. These are examples of data subject requests. All of this leads us to Purview. Purview is what grew out of this Microsoft journey. It's something that we now offer on Azure, and we will continue to get better and better at, that you can use as a customer of Azure. And by the way, we believe in drinking our own wine. So everything you heard me tell you about Microsoft's internal governance will be on Purview. Already, much of it is. So what is Purview? Not surprisingly, this should remind you of the approach we took to begin with. At the core of this is, again, an instantiated catalog of all the data map. And in this talk, I'll tell you how we built this. Automated discovery, scanning, classification, metadata extraction, lineage extraction. We will get better and better over time at the range of sources we can cover, at the depth of the descriptions we can provide. But to begin with, there is the data map, the description of all your data. On top of this, we expose the underlying information through standard APIs. We will see more about that in a moment. But that allows you to build applications on top. We ourselves will give you a suite of applications in the data catalog for data discovery, for search, for browsing, and so on. Likewise, insights, what's in my data estate. But you can also extend this. Building on top of the data map, we give you several capabilities, several applications, if you will, for knowledge workers in the Purview data catalog. You can have self-service, browse, and search for information that may be relevant to you. So in large organizations, the amount of information is vast. And so capabilities to search the data map or to browse it in a variety of ways are extremely helpful in helping you find what you need. Beyond this, when you do find something, you may want to know how it came to be. What is its lineage? How was it derived? Right? So several of these capabilities we will demonstrate to you in just a bit. And if you're not a knowledge worker, if you're a data officer, then you can look at the distribution of your data in a variety of ways, by tags, by business glossaries, by sensitivity labels. And this will get you a good handle on what data exists in what parts of your organization and gives you a head start on what you need to do to govern it. At this point, let me turn this over to Pratik Verma to give you a demonstration of all the capabilities I've described so far in the GA version of Azure Purview. Pratik?
Thanks, Raghu. Let's see how, as a SQL developer, I can use Azure Purview. I work for Datum Corp. As a SQL developer, I'm building an application for sales teams to analyze historical sales data. So I'll log into the Azure Purview portal for Datum Corp to look for the data sets that I can use in my application. I'll type in a simple search that says sales or customer, and as I type, Purview will give me a result of all the different data assets that have been cataloged in the data map in one place. You'll notice there are 500,000 results. That's quite a lot. So if I want to look at just the data sets of interest to me, I can go and filter by different facets. So I'll go look at data sets maybe that have different classification, who's assigned as an owner to it, what sensitivity labels there are there, is there a data dictionary or a glossary term associated with it. So, I'm building a sales application. Maybe I should look at the market development and sales data sets. And if I do that, I can find some interesting data sets that I can enumerate. Let's go drill down into this sales order header table. That sounds interesting because it's in a SQL Server database. I find a bunch of technical information. Let's see what kind of columns are present. So that's pretty interesting. There's some customer IDs in here. There's some social security numbers and a bunch of order numbers. It tells me what's PII here. It tells me a little bit about the description somebody's added in. Who else is using this data? So if I look at the lineage, I can see that this table is being used to compute total due amounts. And then there's also been a copy of this data created to add more details. So let me find out how I can find out more about this. Who's responsible for keeping it up to date? I'll ask Athena, who seems to be responsible data owner for this data asset. Now let's see how Athena made it possible for me to quickly find the data set easily by tagging it with market development sales and assigning a customer ID to this. From this screen, you can see that Datum Corp has lots of different regions and data centers in North America and Europe in different clouds, and you can see all of the data systems that have been brought under management of Azure Purview. Now, Athena is a data owner for SQL Server, so she can filter out specifically all the data systems that are SQL related from all of the data estate in the map here. And you'll notice that there are some on-prem SQL Server here. You've got some SQL Server on Azure and even on Amazon. Now remember the customer ID classification here? Well, Athena can go into the classification rules and create a new custom classification to auto-catalog this from one location. So we'll search for the customer ID classification rule here, click on edit, and you'll see that every time this rule is run, it applies a tag called customer ID to the data dataset. And if you want to go drill further on how that actually works, you'll see that Athena can specify a complex data pattern that does data inspection and metadata inspection to come up with the appropriate tag. And with appropriate scanning configuration rules, you can actually make this classification logic run on not just the SQL Server databases, but any and all systems that are under management of Azure Purview account. This will allow you to automatically scan and classify data across your entire data estate, which may contain hundreds or thousands of SQL Server instances. Now, remember the market development and sales glossary term that made it very easy for me to find the sales order header table? ADATM Corp keeps track of all the standardized terms in the glossary management tool inside of Azure Purview portal. Here, Athena and other data owners come and curate the different data dictionary terms and the lifecycle associated with it. Let's go take a look at the market development term. And you'll see that this market development and sales term is an internal business-facing BU in ADATM Corp, and it's designed for the sales management stuff. And you'll notice that this was approved. If you go take a look at this market development term, you can drill down and see all the different data assets that are associated with it. So if ADATM Corp wanted to find out what the health of the data curation and governance at their entire organization is, they can go to the Insights page inside of Azure Purview portal. As a data officer, you can see how many sources have been kept up to date in this Purview portal for automated scanning and classification. You'll see that there's about 3 million data assets, and you can see the distribution of it across all the different systems. Here's the last cool thing I will leave you with. As you have hundreds and thousands of SQL servers in Azure or other places, you can go in and with one click, register an entire subscription into Azure Purview, so all the many different SQL Server instances there are always fully governed.
All right. Thank you, Pratik. And now the vision in the Microsoft Cloud is that any use of data is always governed by Purview. To this end, I'm going to tell you about a number of integrations we are working on, but keep in mind always, beyond Azure, Purview nonetheless offers you a single pane to extend governance across your entire estate. However, if you are in the Microsoft ecosystem, whether it's Synapse, Power BI, Azure Purview, they're all deeply, deeply integrated. So, for example, if you're in Azure Synapse, the Purview catalog is visible to you through the integrations and allows you to see what data is available for you to analyze to gain insights from. When you look at the labels from M365, from Office, we work very hard to align these with how you see the labels propagate through all your different data transformations, be it to SQL, to Power BI, end-to-end. We give you this view of the labels and how they propagate. If you're dealing with security, Purview information, the data map, can inform and be informed by other tools for security, like say Azure Sentinel, right? All of these integrations will hopefully give you a continuous experience when you're within the Microsoft ecosystem with governance baked in. When you're looking beyond the ecosystem, when you're looking to extend the capabilities of Purview, when you're looking to build new apps, when you're looking to bring in new data sources or new kinds of lineage, right? We want to make sure that this is a platform you can work with. And we build it on open APIs, in this case, Apache Atlas. To illustrate this, let's consider the example of data classification. Within Purview, there's extensive support. There's over 200 built-in classifiers, right, to help you get your data properly marked up. But then, it's still the case that there are some things that are custom, very unique to your environment. And you may, in fact, want to bring the full gamut of machine learning and data science to bear. What then? Here's Lindsay Allen to give you a case study.
This is Lindsay Allen. I lead AI Customer Engineering Team, also known as ACE Team. I'm here to share a real-world example of financial data compliance. The customer we work with is a prominent bank. A lot of financial data are generated daily in the business systems like ServiceNow. The data needs to be classified to meet regulatory compliance requirements. There are rule-based automation in place today, but given the complexity of the business and regulatory policies, a large volume of the financial data required domain experts' manual review. The scalability of this process is not a match to the rate of business growth. Customers engaged with us to create an AI-based solution that can learn and adapt to the changes and increase the degree of system automation. Fast forward a bit, we modeled the business problem as a binary and multi-class classification problems in machine learning. The traditional classifiers require a lot of high-quality labeled data to train and a lack of flexibility desired by our customer. The winning solution is semi-supervised machine learning solution, which starts with an advanced NLP model built through self-supervised training. We then fine-tune the pre-trained model using about 200,000 labeled records. The approach has achieved close to 98% recall, with estimated about 30% of savings of manual work. This custom AI solution could be used to augment the Purview's out-of-the-box classification capabilities through Purview's Apache Atlas API support.
Thank you, Lindsay. Now I think you have a good overview of what Purview offers. I'm going to now take you through one part of what you have heard, Lineage, and show you what's under the hood. So why do I care about Lineage? There are a wide range of scenarios ranging from impact analysis, root cause analysis, monitoring compliance, fair and responsible AI, of interest to virtually everyone who's associated with data in any way, from data officers to privacy officers to data scientists and engineers. Let's take an example. If you consider this SQL query, right, there is a stored procedure executing the query you see here, and it produces an output table based on joining two input tables. And in this case, figuring out where each column of the output came to be, which column of the input tables, of which input tables it came from, is straightforward. You can do this by static analysis of the SQL program. However, static analysis isn't a powerful enough tool. For one thing, when there are triggers, as in this example, you don't know when they execute, and consequently what that does to the lineage of the resulting data. When you have dynamic SQL, even the string that's executed is not known. The actual SQL query is late bound. Yeah. The next example, if there's an if-then, a conditional in your stored procedure, then until runtime, you don't know which branch you're going to take. And depending on the branch that's taken, the derivation of your data will differ. With static analysis, you can only say the output depends on this or this or this input. Whereas in reality, at runtime, you'll actually know that it depends on precisely one of those branches, one of those inputs. Lastly, the nature of transactions. If a transaction fails, the statement you're talking about may never be committed, right? Again, you only know this at runtime. So static analysis will give you lineage, true, but with a big asterisk. And it's going to miss out on a slew of valuable information that's only available to you at runtime. So what you really want to do is take advantage of runtime telemetry. And fortunately, in the SQL Server universe, we have X events. X events contain pretty much all the information we just talked about. Whether it's information about the user running the query, the actual query string that was executed, the timestamp when it was executed, and so on. However, if you try to take all this information in the X events and try to extract lineage in a straightforward way, you are going to have a tough time of it. It's like an overloaded truck. There's simply too much information and too much noise, repeated loops, a whole collection of things that are not of interest to what you're looking to get lineage information on. It's simply too expensive. However, we have put in a ton of work, a whole slew of optimizations, ranging from loop optimizations to eliminating irrelevant events to massive compression. Taken together, we can speed this whole thing up by over 4 orders of magnitude. That's a factor of 10,000 I'm talking about. And that is the version of dynamic lineage extraction that you actually see for SQL Server in Purview. Next time you see lineage for a SQL Server stored procedure in Purview, you know the story behind how it came to be. And in fact, if you were actually to double click on that node in the Purview lineage graph, you would see all the information we just talked about. Let's talk about another kind of lineage. Lineage from machine learning. When you use machine learning to make decisions, ultimately you're relying upon the prediction of a machine learned model. That in turn depends upon how the model was trained, what input data it was built from. And if you don't know this, how can you be confident of the conclusions you drew based on that machine learned model? So lineage is really important here, right? When I train data for a machine learning model, I may be pulling data from SQL Server, combining it with data from elsewhere, and later when I'm auditing the results, I may want to trace lineage back through the use of this model. So provenance is required, but it's easier said than done because the totality of the code involved looks something like this. Let's break this down. First off, some of the data might just be coming from inline parameters. Others may come from SQL Server with a connection string that's specified somewhere in the code. Beyond this, you need to understand all the details we talked about. What are the columns that really were involved, the features that were involved in building that predictive model. Understanding all the libraries, scikit-learn, for example, knowing how these libraries use the features to build models. On and on. The bottom line is extracting lineage for a machine learned model is a complex process. And we have invested in this as well, and soon we will be supporting this. And so to extend our lineage example, all the earlier steps we talked about could be extended by a further step wherein the tables we got are joined as part of a training process. And the output is something where there's a sensitive decision you want to audit, and you want to know if it depended on personally identifiable information. In this example, the lineage makes this pop. Highlighted boxes tell you that there is indeed that kind of dependency. Next up, let's briefly talk about responsible AI and the role of machine learning. Machine learning uses data to train models. And based on the output, the scoring of those models, you make real life decisions. If you want to know that those decisions are fair, you need to be able to trace the impact of the data that the machine learned model was trained on. Let's go take a look at another aspect of Purview. So far, we talked about the data map as a way to get a comprehensive view of what data you have in your data estate. But then, as you know, in SQL Server, you can go in and use role-based access control to say who has the right to do what with any given table. Grant, select, revoke, grant, commands like this we've been using for many decades. In general, if you think about governance controls, it's not just access control. You also want to think about encryption, location, sharing, retention. All of these things you would love to have policies that you specify and the system enforces. For example, only Microsoft FTEs can read highly sensitive data. And notice something in what I just said. I didn't restrict my statement to an instance of, say, SQL Server. This is a statement about my entire data estate. Today, we'll just look at one particular kind of policy, access controls. Okay? Allow read on data asset customer to Alice. Only Azure FTEs can read PI data. These kinds of examples. You want to be able to specify these policies in a central pane of glass, the Purview pane of glass. And you want that then to be enforced on all the data, no matter where it is in your world. So let's see how this works. I have the central pane of glass for Purview in which I can specify my policies. So there are two example policies here. Allow read on customer to Alice. The second example, allow SQL Performance Monitor access on data contained in database 1 to Alice. These two example policies, let's see how they play out on your underlying data estate. The thing to keep in mind, I asserted the policies once, and now I'm going to see their effect on all the underlying data repositories. I didn't go to them one by one and specify what I wanted. Okay? So in the first database, SQL instance 1, there's a single table customer. Alice is able to access customer as well as the underlying system tables. And that's because the centralized policies, which were specified by the Purview administrator, they have been pushed down, and he's gotten the right to view these tables in database 1. If I take the second database, the second instance, here the local administrator has further restricted the global policy. He's basically said Alice has deny on customer table. So the right to access customer has been overridden here. And so Alice would be able to look at the system tables, but not the customer tables. If I now go to the last example, here the database is such that the system table access from above doesn't apply because that was restricted to database 1. On the other hand, I haven't overridden the access to customer, so Alice is able to see the customer table. And if a local database administrator wants to know what rights are in effect, because now what's in effect is a combination of locally specified policies and globally specified policies, they can see that in the underlying DMVs, right? The dynamically managed views. All right, let's see how all this works. For access to the system tables, Prasad will now give a demonstration of how that works in Purview today. Prasad?
Hello, and welcome to this demo of Azure Purview and Azure SQL DB. I'm going to show the upcoming central access control feature of Purview that allows you to grant access to multiple system DMVs across multiple SQL DB in your data estate. As a DevOps user, I want to collect a lot of system performance related data from the SQL Server by querying a number of different system DMVs. So for example, if I am now connected as, let's say, a user Haley to this SQL DB, and in order to execute this query, I need a read permission on this particular table. For me to do my job, I need access to a number of such DMVs, and not just to one SQL Server, but perhaps all the SQL Server in my resource group or my subscription, which is a lot of work for your DBAs to individually go and grant permission to these users, not only to your existing set of SQL servers, but any new SQL server that lands in your subscription or resource group. Now let's look at how we can address this using the new centralized access control in Azure Purview. This is my Purview instance, and I have my data estate registered in this Purview. And as you can see, I have a couple of SQL databases that are part of my data estate. And as an administrator, I want to give access to a number of DevOps users to do various performance monitoring system DMV queries across both these SQL servers. So let's go to this new policy studio in Azure Purview. Let's go ahead and create a new policy. We'll name it Finance DevOps. Now, a policy is made of a number of policy statements, and a policy statement basically allows you to set a permission on a specific action against a given data source. So in this case, I'm going to select SQL Server, and let's say first I'll pick up my first SQL Server here and grant this performance monitoring access to a AAD group called GSL. And then since I want to cover both my SQL Server, I'll add another policy statement, which also gives that performance monitoring permission to my second SQL Server. which is this. And I'll give this access to the same GSL group. Now let's go ahead and save this policy. So at this point now I have this policy created in Purview. It's essentially sitting in a draft mode. As you can see, this policy is sort of a more simple, business user-friendly, intuitive, readable language. It says allow SQL performance monitoring to data contained in Jim Gray to a group called GSL. Now I want to take this policy and make it effective against the target data sources. So that's the process of publishing this policy. So it shows me these two data sources, SQL data sources that are available in my data estate. So I select these two and publish my policy to both these SQL servers. And so at this point, Purview is going to send these policy to these two SQL servers for them to enforce. Note that this is a asynchronous operation, so it will have a certain SLA for these policy to be effective on these SQL server, typically in few minutes. So after waiting for a short while, I'm going to go reconnect to that SQL database as the same user. And now I'm going to go and try that same query that I was running to get data from the performance monitoring related system tables. And as you can see this time with the Purview policy, I'm able to execute this query on this particular SQL server. So that essentially shows how you can make set these policies centrally from Purview and have them enforced across different SQL server so that you don't have to repeat that for each different server for different group of users. In upcoming Purview and SQL Server integration, you will be able to do this at the resource group or the subscription level. So a single policy essentially will cover all your SQL servers, the one that are existing as well as the new that gets added in future to your subscription or resource group.
Thank you. And now those same capabilities will shortly also be extended to user data tables, right? Prasad, could you illustrate that, please?
In this demo, I'm going to show a sneak peek of the centralized access control that we are building for the user table access in Azure SQL DB. So I'm connected to this SQL DB in SSMS with my AAD account. And from this database, I want to say run a query against a table called stores, which at the moment I don't have access to. So when I run select from stores, the query fails because of the permission error. Now, let's go to Azure Purview and provision the access for this user table. So this is my Purview policy authoring experience, and I'm going to create a new policy to give my account access for this stores table. So I'll call this policy as vendor reports. And I'm going to add a policy statement that gives me a read permission on this SQL table. So I'm going to paste the full qualified path of these tables under my DB1 database. And I'm going to provision this access for my own AAD account. So now I'll save this policy. And as a next step, I will publish this policy to the SQL DB that is registered in this purview. So once I publish the policy, it will be handed over to SQL Server for enforcement. This is an asynchronous operation which takes a few minutes. Now I'm going to connect back to my SQL Server and execute that same query. go to that database and submit the query to read data from that same stores table. So when I execute the query this time, I get the data from the table because now I have a policy defined in Purview that gives me a read access on this table. Thank you.
Thank you. We talked about essentially the capabilities you have today in SQL Server, except instead of going to each instance and specifying the policy, you are able to say this once in the Purview pane of glass and have it apply to all the databases underneath. However, we are working to enhance all of this even more. So now let's talk about attribute-based access control. They extend the familiar RBAC policies with one important extra feature. They can hinge on conditions. In this example, I'm basically showing you how you can deny access on PII data to everyone who's not a full-time employee. So the condition here is that the data is tagged or marked PII. Here's where you see the powerful synergy between the scanning and classification of the Purview catalog and this ability to assert conditions based on how the data is marked. How does this work? The policy is authored in one place, centrally. The enforcement is federated close to where the data is for efficiency. So the underlying data, the underlying databases could be on-prem, could be in Azure, and there could be many different databases. In each case, we want to make sure that the centrally specified policy, the relevant portion of it is pushed to each of the underlying sources. And when anyone tries to access one of those underlying sources, the right things happen and they happen efficiently. Let's see how that works. In order to do this, first, the centrally authored policies, you need to have a reliable, efficient way of pushing this information out to the underlying sources. That's policy distribution and execution and caching. Next, when someone actually tries to run a query against one of those sources, the normal execution flow must be suitably modified that it takes into account the portion of the policy that comes from this global system. In addition, of course, there could be local policies, in which case the combination of them must be enforced in a semantically rigorous way. In summary, Purview is creating a new data pillar of unified governance across the entire data estate. And as we do this, we are making sure to integrate this from the ground up deeply with SQL Server, extending its governance capabilities significantly. In fact, you can think of Purview in two ways: a new universal pane of glass for governing your entire data estate, or the next generation of governance for SQL Server. Thank you.